maybe now it's better. I think it was activated, so they cannot hear at all, or?
No.
If you want to
Just stop sharing. So can you just go back onto StreamYard? Sorry. So settings. Audio.
It should be. It's picking up my. Is it better now? Like, can you check online if?
Just select the drop down arrow. Okay, speaker. Okay. If we can.
Yeah, they can hear you.
Can you hear now? Okay.
Right.
Whatever we did, fixed.
So if
fixed
you want to
that.
go back to share screen,
Yes. So this will be able to see the screen.
it's back onto StreamYard. Present.
Yeah, should be fine now.
Yeah.
Sorry for that. I will try to repeat myself very quickly, though, for those online that they couldn't hear us. So I guess you've seen the slides. So I didn't say anything that deviates massively from the slides. But in a nutshell, for those online, what I said is that within the 4 universities, we have extensive expertise in AI, covering the entire spectrum of AI, and the same thing can be said for the agri-food systems. So I think if something we can keep from the message is that if there are any ideas about co-creating some projects, if you are an industry partner that is facing some issue within agri-food, I'm sure within the 4 universities, we have the expertise both from AI and the non-AI component to accommodate that. So obviously within the project co-creation component, and we have a few examples of that from cohort 1, when we discuss with companies, we try to kind of listen to them and see what they have to say, the problems they are facing. And the idea is that we want to make sure that the investment that is provided by the company, there is a clear pathway towards developing something that will be useful for them, alongside obviously the PhD students, publishing papers. That is something that they need to do anyway. But as I said before, there's a strong stakeholder engagement component throughout the co-creation of the project proposals, but also at the delivery of the project. So in projects that run at the moment, the meetings sometimes, not every week, but whenever that happens, we have the external supervisor from the company, we have the supervisor from the other universities. So there's kind of more collective perspective to that. And all students can use facilities that we have across the 4 universities, with another unique aspect of our offering. So for instance, go Lincoln University, they have a strawberry farm and other facilities. Then if a student needs to use these facilities, then they can use them within the partnership agreement that we have. So it's not. So we are quite collaborative even within the 4 universities that we are part of Sustain. I'm not going to go into much details because I have already mentioned that. You can see here some of the areas that the University of Lincoln is specializing from the AI perspective. We have agri-robotics. So Lincoln is doing a lot of stuff in agri-robotics. They also have other programs focusing on agri-robotics, but they've also expertise in deep learning, machine learning, AI, broadly speaking, planning, goals, and so on. And the same thing can be said on the agri-food side. There's a, yes?
I'm sorry, can you share your entire screen rather than your slides?
I'm setting the entire window of, I don't show the slides. I'm not showing the slides.
So if you just go back onto share, stop sharing, present, share screen, entire screen, and now share.
Okay. So hopefully we've resolved all the problems. Fine, perfect. So Strathclyde, similarly, they have a strong expertise in AI and applied AI, but also they do a lot of stuff in remote sensing, Earth observations, IoT, computer vision foundation models, and so on. Queen's Belfast, they have lots of facilities. Actually, we're fortunate to be there back in February. So all our students have the chance to see the state-of-the-art facilities that Queen's Belfast is having. They have the Momentum 1.0 Institute. We spent a few hours there and see some of the stuff that the people in Queen's are doing. So they've had long history in livestock, animal, and so on also. So Elias is here in the audience. He's a professor of veterinary sciences at Queen's Belfast. So if you want to chat more about Queen's today, feel free to catch Elias over lunch. And Aberdeen University, again, as I said, AI, we have more than 40 plus academics focused on AI, core AI systems. But we also have, as I mentioned before, in the other campus at the medical school, we have Rowett Institute, which is a nutrition institute in Scotland. They do a lot of stuff in food security, food policy. So they are strong experts in nutrition. So some projects could involve Rowett, if that's the area of interest. But over this way, if we were to walk that way where I'm pointing, there is the School of Biological Sciences. They have very strong expertise in soil sciences. They do some carbon sequestration, modeling, and so on. So we have strong expertise in these areas. Now, this is our first cohort, our cohort 1. We have most of them in the audience here today. And as I mentioned before, we already have a very diverse cohort covering different areas within agri-food, livestock, crop management. Many of them, they're working with companies on real-life problems. You're going to see an example in a while also. And we are very keen to carry on the same conversation and meet new partners and expand our networks to create new PhD proposals. An example of a PhD student, Athena, that we have here today. Athena, she's supervised by myself and Aidan Duran here at the University of Lincoln, and also Mama Fathota from Aberdeen University, and Mama Fathota from the University of Lincoln. And she has external supervisor from Advanced Plant Growth Center, Derek Stewart. And we have today, I'm very glad that Tanvi managed to join us today from Intelligent Growth Systems Solutions. And this is a picture from the facilities back in December when we visited that, and you can see Athena and others having a nice deep conversation about vertical farming. So that's an example of a student's journey, starting actually getting to know each other more than a year ago, thinking about what problems exist within the vertical farming context, and then thinking about what we can offer from our perspective. We wrote the proposal, we found a very good student, and then the project is now ongoing. So we are looking at similar examples, and I could pick also similar examples from other students. And cohort 2, for instance, we have a student that he's going to be joining us in a couple of months' time, and he will be working with Ian, that you're going to hear from Ian in a while, from Waterside Pharmaceuticals on a different project. And yeah, all our students have similar journey, just to give you an idea of what type of projects we are looking for. And without further ado, I just want to finish with that, saying that we are now inviting proposals from supervisors for our round 1 call for proposals for cohort 3. So students are going to start October 2026. And as I said before, for us to have a very good proposal and supervisors to submit something that's competitive, they need to have some strong engagement with industry stakeholders, hence the event today. So if you have an idea, if you're an industry person here and you have or online and you have an idea, you have a challenge that you are facing, we would like to hear from you. Please reach out to us either via myself now or via Sustain, and we're going to try to identify supervisors from the other universities to co-create something that is competitive. So that's it from me. I'm not going to hold you any longer. Again, thanks for coming along. Thanks for traveling to Aberdeen. Thanks for being online today. And without further ado, I would like to introduce Professor Simon Pearson. He's from the University of Lincoln, and he's going to talk about AI in agri-food, that he's been working in this area for many, many years. If you want to point there, no worries. Thank you.
Is it working?
Yep.
It's clearly not AI enabled, is it? Okay, thanks. So thanks for the opportunity to come here. It's just brilliant, isn't it? I come to Aberdeen and it's not raining, and I don't know what to do. I've got all this luggage, my Southwester in it, and I haven't been able to wear it. Hold your breath. Okay. Yeah. What an amazing place this is, though, isn't it? It's beautiful. So yeah. So thanks for the opportunity. So I didn't quite know what I was going to say today, but I think hopefully it's a message of hope, really, because I think there's so much going on the food system, and I just want to reflect on some of that, and so much going on in AI. It's incredibly fast paced, isn't it, really? And there's an awful lot going on around AI adoption, which is going at a rate I think everybody has surprised. Well, it certainly surprised me anyway. I mean, there's an awful lot more going on in the industry and adoption than I think most people realise. In fact, AI is probably everywhere, isn't it now? And I had a reflection. I gave a talk to it was a farmer conference, and they had a little load of booths, a little industry thing before the conference. Lots of companies showing their ware, and this was about 6 weeks ago, and it was to people who grow herbs, and there was about 20 companies who had booths at this conference, and I went around those 20 companies, and bear in mind this is quite a small sector of the agricultural industry, fresh herbs, and about half of them all were selling AI-enabled technology, whether it's a vision system to do weeding, image recognition, whether it's a vision system for online grading, whether it's some sort of decision support tool. And I thought, well, that is quite extraordinary. When you've gone from a position, if I'd gone to there 2 years ago, naught of those companies would have existed. And now half of those companies were offering an AI-enabled tool. So they're not really AI companies. We don't think of them as AI companies, but half of the products there had AI as the decision tool, and that was the added value in their products. And I thought, bloody hell, that's amazing. And actually think of it, most of it is fairly simple AI. It's sort of deep learning-y stuff, image recognition, vision systems. And that's really before some of the sort of the latest stuff has really started to take off. So I sort of came away from that thinking, goodness me, where is this going? And then some of us in the room, so I'm a member of the FSA Science Council. I look after AI for the Science Council and AI implications in the food system. And then some of us, including some students, and Cassie. Where's Cassie? Is she here? No? Yay, there you go, George, and yeah, quite a few of us, Simon. We had a meeting, what was it, 2 weeks ago in London, where we invited lots of people to talk around the implications of AI in the food system. And there's several things I took away from that meeting. One, the quality of the people in the room was amazing. So we had the head of food safety for Nestle flew in from Switzerland to be there. Had a guy from Google, got a salesman from Amazon who did a pretty good job. But some very, very, very senior people from industry who you wouldn't normally see turn out for a standard FSA meeting. So a standard FSA meeting, people go, oh God, that's going to be boring. It'd be about regulation. But we had lots of really, really high quality people there and a very lively debate. And through that debate, again, I came away thinking, blimey, this is really happening. So Nestle guy was really interesting. They invested €1 billion in a data center, which they built under a lake in Switzerland. And it contains every single bit of data about Nestle, from the Kit Kat you probably ate on the train coming here, to the cat food that you feed to your pet. It's all archived in Switzerland. Extraordinary, and then extraordinary use of AI now to interrogate that data. down to lots of meat companies who are using it in meat processing. And yeah, so it's absolutely there. And then what I think the other overriding things, people thinking, well, it's coming up so quickly, they don't really understand it. So there's all sorts of concerns. And then obviously the government's concerned about things like regulation and trust and all this sort of stuff that's going on in AI. So when you wrote Sustain, which I think was 2 years ago now, yeah, you had to, at that time, you had to sort of try and look forward into the future around what AI was going to look like. And then you had to define what the challenges were going to be in the research challenges. And I think you got it really spot on, actually, because you talked about the technical stuff. And as you said, George, you talked about the explainability stuff, and you talked about the trust stuff. And actually, 2 years on, those are the absolute really live and serious questions which are being asked now. So I think you've got it absolutely right. You're absolutely in the right place. So I think it's very, very important time. And I think Sustain is incredibly important. And I think if you're a PhD student within the CDT, you've got an absolutely brilliant opportunity to use this as a launchpad for your career, really, because I think you're going to be very, very valued. The skills you're going to learn are going to be very, very important, and I really hope that it sort of underpins some fantastic careers, whether they're in AI or whatever you do. I really hope it gives you a really good grounding and a framing for whatever you do in your next steps. But at the moment, you're absolutely on point. And then the other great thing the other good news which came out this week, which I'm really proud of, and it's great to see, is the industrial strategy was published this week. And with all of the crap that's going on in the world, I think it's sort of got a little bit missed by the press, actually. And but actually, if you go back to it, have a read of it, it is really very, very important. And if you read the industrial strategy, you'll see it is riddled with AI. And I think we've all seen the press. I think the government's have got it. I mean, AI is now seen really as the accelerator of growth across the whole economy. And there's multiple interventions in there, going all the way from skills. And you'll seen last Monday, so it was Tech Week. I think the government announced, was it 500 million for AI skills going in, and that's to upskill people in the economy, all the way from operatives on production lines, all the way up to managers, to AI developers. So some really big investments are going in. Huge investments for innovation, so which is fantastic, again, across all sectors of the economy. And then the really good news from my point of view, and I think hopefully our point of view, is that in the advanced manufacturing strategy, agri-tech was one of the 6 foundational industries. So that is really, really good news. And the government's announced £200 million of further investment in research and innovation for agri-food, agri-tech. So it's a big amount of money between now and 2030. That's going to be deployed by DEFRA and Innovate UK through the Farm Innovation Programme. So that will keep that funding stream very, very active. In fact, it's increased, and AI will be a very, very big a strand of that. So lots of money going in, and that will keep everything moving, I think, for the next few years. But the other thing for all of us here is that because we're in the industrial strategy, that's a signpost which we can use in any grant application, any discussion with government, whatever you like. Because we're in, that gives us leverage with government. So and that means leverage with UKRI, that means leverage with DBT, that means leverage with DEFRA, the whole lot, because we're in there. Because you can now signpost whatever you do. So we're in the industrial strategy. That is one of the government's key growth missions, agri-tech. We can use that, and we can use that as leverage. So that's, I think, it's a soft tick, but a really important one. If we weren't in that industrial strategy, it would be bleak, because the way that the government's going, they're going to focus all of their efforts around these key growth areas in the industrial strategy. So, so we're in. So it's really good news. Now, so that's that. Now, why is it really important in the food industry? And I'll bugger it up, George. Need a computer scientist. Hang on, he's going to turn it. He's going to turn it on and turn it off again.
Not quite. But...
I told you he would. There you go. He's got a degree in computer science. He's probably got about 4 degrees. He's got about 4 degrees in computer science.
For good use, right?
Yeah. So why is it great? Well, I think it's really great, and I've used this slide a lot, but I still think it's really important. And I think the other great thing is about AI in agriculture. It's AI with a purpose. And I think when you're doing stuff, it's great to have a purpose. And you could do stuff in fundamental AI. You can do stuff in more applied in the agri end, but whatever you do, it's got a purpose, particularly in this sector. And huge industrial challenges. And if you look at the industrial strategy, still there are actually 3 areas where the industrial strategy is prioritizing for agri-tech. One is on sustainability and core sustainability, so reducing climate impacts, having a more resilient food system, stuff like that. But the second one, actually, which is great to see, is that there's still a big push on robotics, which really is a physical manifestation of AI, and that's around driving labour productivity because of migration issues. So robotics has come back very, very strongly in the industrial strategy. And I show that picture there, and that picture in the top corner is a picture of a daffodil picker probably in Cornwall. And I've mentioned this to several of you, but I used to run a daffodil company. We employed 900 people, spoke 26 different languages, and most of those were operating in Cornwall. So if you ever went into Cornwall in the winter, all of the caravan parks in Cornwall filled with my daffodil pickers who are picking daffodils, and they're doing that for 7p a bunch. So a miserable bloody job, and we don't have people want to do that work anymore. So AI is going to be really important. The other area where I'm really interested in is things like productivity. So I put that fruit and veg thing really to talk about some of the social issues in the food system. So we've got this massive obesity problem. We want people to eat more fruit and veg. How do you do that? Well, the easiest way to do that actually is not complex social science and nudge theory. That's all great, but actually the easiest way to get people to eat more fruit and veg is just to make it cheaper. And that's all about productivity. So we need technology to drive productivity, and AI clearly is going to be a key enabler. And then the climate change one's really interesting. I'm really pleased with this one, that we've got a big focus on the opportunities to reduce climate impacts of AI. And I'm really pleased in Sustain that we've got plants as well as animal systems in there. And if you, one of the great problems of food industry climate change is lots of the carbon emissions, 37% total carbon emissions are from food chain. A lot of those are biologically driven. So from animals, ruminants are always blamed, poor old ruminants, but there's lots of opportunities hopefully to drive efficiency in terms of reducing some of these emissions from the animal system. So AI, I think, is going to be key. And then the new one recently, I put tariffs on, which is going to be amazingly complex because we're going to see dynamics and changes all over the place. I'm sure AI has got a role there. What's going to happen? So What happens if China puts a counter tariff against soya exports from the United States? Where's that soya going to go from the United States? What's going to happen to the market? Is that going to affect deforestation in Brazil? And all the, there's unbelievably complex questions, which I think probably is a really good opportunity for AI to get involved in terms of answers to those questions. So I think AI is going to have a big role. So you're absolutely on point. There's lots to do. There's just an infinite amount of stuff that can be done in this space. I'll keep going. Where I'm also really interested, and this is what I use for the AI workshop. When we did the FSA workshop, we did the workshop where we asked people to consider 4 use cases of AI in the food industry. And I can tell you I made them all up about 2 months before the actual workshop. And I had no idea really what was going on in the food industry. And we looked at 4 different things. We looked at risk assessment, so using AI to assess risk. And we were particularly there interested in very complex risks, particularly associated with complex food products. So if you're a manufacturer of food and you're going to change an ingredient in a food, you've got to do a complete risk assessment, particularly around allergens, of everything that's in that food. So every time you make a minor change, you've got to completely risk assess the entire thing. And that there's armies of people around the world who is continuously doing that. And if you've got new products, it's really complex because you're starting fresh. So you've got to do all this risk assessment stuff. And then before you can launch a food, you've got to be confident that you've managed all the risks, or you've got a legal liability if somebody has an allergen or whatever. So really complex. So we thought, well, actually, that's interesting. So we could see a world where AI is going to be really informative in that. And then we felt, well, it won't be one thing, singular AI. It'll be a series of AIs. And we were talking about LLMs, knowledge graphs, multimodal AI. So we could see a world where these 3 things, at least, or 4 things, or 5 things, could come together to actually solve this problem. And I think as we evolve, we're getting more to that state where we're starting to realize, as George said earlier, AI is such a huge and diverse thing. Actually, the interesting challenge is how we pull all these diverse things together to have an impact in on one industrially significant thing. So risk assessment, you can see, you could talk, probably there'll be 3 or 4 AI systems involved. And the interesting, when we got to the workshop, was that we discovered very quickly, and I had no idea, that Nestle are already doing this. So actually industry is moving at pace. So if you're an entrepreneur, which I hope many of you are, you need to be really acting fast for this stuff because industry is thinking about this at great pace. Then we did one on what we called audit assurance. And then we thought about the misery of being a small farmer when it comes to audit. And if you're a small farmer, it comes to audit. It used to be the case where you had to do an audit. If you supplied Tesco, you had to do a Tesco audit. If you supplied Asda, you had to do an Asda audit. If you exported, you had to do a global gap audit. And then you might have to do a red tractor audit. And there's just a bonkers amount of audit that has to be done. And every time you do those audits, it's basically a paper chase where you're collecting all these records. They're usually in a file. And you've got to put it all together, and you've got to prove to these auditors you're doing the right thing. So clearly, there's an opportunity for AI in just managing all that process. So we talked there about NLP, we talked about RAG, we talked about rule-based AI, and all this sort of stuff to accelerate and take the misery out of all that job. So we can see AI being there, but again, it's not one form of AI, it'd be multiple forms to solve that problem. But also we heard one of the people at the things already developing these products. And then it's a question of how good they are, and then how do you test them. Next one's abattoir inspection. We train hundreds of vets every year. Ilias does a few of them, I'm sure. And then a lot of the veterinary jobs in the UK are pretty unglamorous. And you can be a James Herriot vet wandering around Yorkshire in a lovely car, but there's really not many of those left, are there? Or you could be a factory meat inspector vet, and that is somebody who sits in an abattoir looking at the eviscerated guts of chickens going past you at 20,000 birds an hour, which is a bit less glamorous than what you see. And clearly that is not a great use for the skills of a trained vet. And you can imagine AI being very actively used in that. And there you're going to need image recognition, edge AI, deep learning, transfer learning, all these sorts of things. What's clear again at the workshop was that there are lots of companies now already selling those products into the market. Now, how good they are, nobody knows. What standards are, nobody knows because there aren't any. Do they explain what they're doing? No, they don't, because nobody's asked that question yet. So there's this sort of wild west of companies already out there doing this stuff. And then the final one we did was port documents. So if you are importing stuff into the UK, let's just say it's soft cheese, when it comes into the port, FSA have inspectors in there, and they've got a real problem. So there's going to be like thousands of stuff coming in. What are the standards for soft cheese? Well, nobody knows because they don't see that much of it. So how do they retrieve that document? How do they show that that soft cheese is legal in the United Kingdom? How do they show that it's been produced to the appropriate standards? How do they show that it's assured and safe? It's a really complex problem, and there's an army of people doing that stuff. And then we talked about there, well, that might be done by LLMs, by anomaly detectors, all sorts of different forms of AI. Anyway, it turned out on the actual day, it turns out that FSA has already done a big investment in port document inspection systems using AI. So the point is here, so we imagine those four things 4 weeks, 5 weeks out from the workshop, but it actually turned they're all being done. And to me, that just demonstrates the pace which this is going on. But also it demonstrates to me the opportunity within this space. So lots of challenges. On the sort of the ethical questions, and so how do we ensure transparency, traceability, auditability? What are the standards? And I think when you go through, I hope when you do your PhDs, you also think about science standards for this stuff. And I don't think we've really seen much of that yet. Maybe it's out there, I've not read it. But what are the science standards? How do we prove that this thing's working? How do we know it's robust? How does it work in many environments and all those things? We've not really got there yet, because I think there's lots of people selling stuff, and we've not actually seen lots of it in action. So how do we monitor bias, drift, data quality? And these are all the sorts of things I hope in your PhDs that you're going to be thinking about when you do it. I mean, that to me, the great opportunity here is not being in a startup, not pushing out stuff into the industry, but the great idea, the great point about what you can do is that you can do really high quality science standards to underpin all this stuff as it comes through. And I hope when you go through that's one of the things that you're left with. So great opportunities for AI. I'm not going to say much more, but also we're very keen to support students as best as we can. Sustain has you've got a great network of people to work with, and that's industry mentors, that's academics, a great network from across the 4 universities, but a great network across the whole UK and hopefully globally. So use those networks as best as you can. Also, we have other networks. At Lincoln, I run a program called Linkham. So if any of you want to commercialize your stuff, create spin-outs or start-up companies, we also have funding to do that. So if you're interested in that, you've got a great idea, we can fund late-stage PhD students, probably not in year 1, but probably in year 3. So if that's something that interests you, again, keep in touch with us and we can try and help as best as we can. So we've already started a number of spin-out companies. There's one at UEA, there's a couple going in at Cambridge. We've got it will be now 3 at Lincoln. So if that's something that of interest, again, if you think you've got something, you want to take it forward, you want to be entrepreneurial, you want to give it a chance, again, keep in touch. So that's it. I'm going to stop now, but wish everybody the very, very best of luck. And I think what you're doing is amazing. You're absolutely on point. And I just wish I was your age and I could give it a go.
Great. I don't know if there are any questions. We can take now if we have a bit of time. If you have any questions now for Simon, feel free to raise your hand or online. We'll have time at the end if you want to ask questions about everything that we've heard today. But if you have any burning questions now, raise your hand. Okay, if not, then I'm going to welcome Ian, that he's going to walk us through the challenges that they are facing in medicinal cannabis growth. What was the... double check again. No, because it says sharing. Perfect.
Okay.
Great.
Great. All right. Hello. Thank you for inviting me today. It's really great to talk to you. So I'm in place. I'm representing Waterside Pharmaceuticals. We're a medicinal cannabis startup here in Aberdeenshire. And we've arranged a PhD project with Sustain, looking at the applications of machine learning in cannabis cultivation. So as I mentioned, we're a cannabis startup, medicinal cannabis startup in Aberdeenshire. We started a couple of years ago, but the process of getting licenses and registrations taken about 2 years. So we've recently started producing plants. I can actually show my own photos of cannabis cultivation for once, instead of pulling them off the internet. So we started about 2-3 months ago. We received our first batch of plants, and we're looking at producing our first harvest July, August time. So the focus of our company is providing cannabis-based products, so either dried flower or in the future, or working with other companies processing our product, derived things like oils, gummies, things like that. For medically prescribed patients via authorized clinics or pharmacies. So we're working with Curaleaf and Relief, and they both provide an outlet for market for us, and they also provide support for doctors and patients. And what's unique about our facility is that we used to be a vertical farming company. So we have a controlled environment agriculture setup already. We've renovated it as much as we can for cannabis production. So this enables us to have as much control over crop production and crop steering as physically possible, so long as none of our equipment breaks. But you know how that goes. So a bit of a background on medicinal cannabis. It was legalized in 2018, so long as you have a prescription. This includes dried flower directly, and also any derived products from that. So the first instance of that was a THC extract produced by a company used to be known as GW Pharmaceuticals, located down in Kent. And that was predominantly for the treatment of epilepsy. But there are also other conditions such as multiple sclerosis, and also treating the side effects of things like chemotherapy. So how cannabis does this is by interacting with what's known as the endocannabinoid system. So the naming system is a bit backwards. There is a system called the cannabinoid system in all mammals. It interacts by controlling the transfer of neurotransmitters across the gap between synapses. It just so happens that it sort of got its name from the plant rather than having its own name. So it's a little bit confusing. So endocannabinoid simply just means the chemicals your own body produces, as opposed to chemicals produced by the plant. So it's, my background isn't in neuroscience, so I can really tell you it's involved in a huge variety of processes, including pain regulation, mood management, appetite management, an enormous quantity of processes in mammalian systems. Now, THC, which is the predominant psychoactive cannabinoid or tetrahydrocannabinoid, interferes with the system. And what's interesting is that it's structurally similar to the chemicals you produce in your own body, enough to essentially trick the system and override it. Now, what it overrides is, so the endocannabinoid system is like a negative control system. I could just share that. So you've got, there you go. The presynaptic cleft and the postsynaptic cleft, and you've got the transfer of an inhibitor chemical. If that hits the receptor, any kind of neurotransmitter, dopamine in this example, cannot pass or be transmitted, and a nervous signal cannot pass through. That's when there's no activator for the cannabinoid receptor, the CB receptor. It's a little bit blocked by the thing there, but essentially THC can bind with that receptor, which prevents the inhibitor, and it allows whatever neurotransmitter to pass over the synaptic cleft. And that's essentially how the psychoactive effect of cannabis is caused. And it causes a variety of psychoactive effects. It's obviously not quite that simple. THC is one of over 100 cannabinoid chemicals in that group. That includes things like CBD oil, which I'm sure you've all come across, isn't medically restricted because it's not psychoactive, and many other potentially precursors in the chemical pathway to producing THC. In addition, it's not as simple as you can just create a THC extract. There's what's called, well, it's basically an effect of all the other chemicals the plant produces, so things like terpenes, which loads of plants produce. You've got terpenes like linalool, which is found in, like pinene, you have found it in pine trees. You have, it's how we have different, what's called flavors of different varieties of cannabis. They come from the terpenes or flavonoids found in various different plants because it's the same chemical pathways. And lavender is linalool. Sorry, forgot that for a sec. So that's broadly how THC and cannabis products affect patients. There are, of course, challenges to, first of all, getting that product to patients. It doesn't work like how it works in the US or Canada, where you have dispensaries. There needs to be a prescription, and that prescription has to go directly to a patient. Getting a prescription is challenging simply because a doctor needs to have special training to prescribe what's called cannabis intended for human consumption specials is the legal designation. And there are not many doctors in the UK currently who are able to prescribe such a prescription. But that's not really my expertise. There's also quite a lot of challenges in producing the crop. So as I say, we used to be a vertical farming company. We used to produce things like basil or even chili peppers. They're very simple in comparison. The production cycle is very, I don't want to say easy, but not as complicated. So just to give a brief overview of the cultivation process, the first challenge you have is that cannabis varieties are not very genetically homogeneous. So if you have a good phenotype, you can't reliably reproduce that. And also cannabis is a monoecious plant, so there are male and female plants. That's a large challenge for genetics. There simply hasn't been a huge focus or funding or resources in producing reliable strains. So to counteract that, we clone our plants. We simply take cuttings. We let a plant grow under normal conditions, don't make it flower, and just take cuttings from the plant. This produces something about this size. We root them in really humid conditions just to stop them from drying out. We let them just grow roots so they can develop into being their own plants. Then this is the only part where we actually use our vertical farm. We put the plant in long day conditions and we let them simply recover from the cloning process. and we let them grow some leaves and bulk up essentially at this stage. Then we transfer them to our flowering rooms, and the big change at this stage is that we switch it from an 18-hour day cycle to a 12-hour cycle. So in nature, a cannabis plant growing outside would get to about autumn, September, when the days start getting shorter, and that triggers a biochemical change in the plant that triggers, I need to start producing flowers, winter's coming, I'm not gonna be able to live for very much longer. So you can trick the plant into thinking it needs to start producing flowers by knocking it down to 12-hour day lengths. Then after a few weeks, you start seeing these flower buds appear. The small white structures are essentially pistils, which catch pollen out of the air. Cannabis is wind pollinated. They develop further, they start essentially getting larger, and you can actually see it far more clearly in this photo, but you see the small white dots appearing on the leaf and on the buds themselves. Those are trichomes, which are essentially that specialized tiny little hairs that are the chemical factories that produce all of the cannabinoids that give the plant its medicinal value. Unfortunately, they're also very fragile, both physically and to environmental conditions. So you need to be incredibly delicate while handling the plant pretty much once it starts to flower. So moving on to harvest. Harvesting is pretty simple. You take the flower buds off the plant, you move them to a cooler environment where they can dry off. You remove the leaves that are growing throughout the buds because these can contaminate the end product and also make the product, if it's going to be vaporized, it can make it quite harsh on the patient. And then you dry the product for 1 to 2 weeks just to really get the moisture levels low, which reduces the chance of mold or contamination. And given that these are going to people who have been specifically prescribed, that's incredibly important. And the testing to actually get past that is very strict in terms of microbial content. So where do the challenges come in? So every day I have to monitor the plants, obviously visually, and that has a couple of problems in that obviously one person is subjective. It takes a lot of my time and I have a lot of other things to do in the facility. Having some kind of automated system that can sort of detect essentially how a plant is doing would be very valuable for us. And in terms of what could go wrong, you're looking at sort of pest and disease activity. So you've got spider mites and then mildew. Unfortunately, we've come across 0 yet, I'm crossing my fingers. Or you just have imperfect growing conditions, and none of the people at our facility are experienced cannabis growers, and you can only know if there's a problem when symptoms on a plant start to show. So here you've got something as simple as you're either not supplying enough water to the plant to flush the nutrients out of the soil, or any of the other reasons a plant leaf might turn yellow, which if you have house plants could be any number of reasons. So this is time-consuming, subjective, and it requires having experienced staff, and the process of developing an experienced base of staff is a long process. To be more specific about what we're looking at and what could be a first step in the PhD project that we're designing is automatically monitoring plant development and identifying variations in performance. So being able to monitor plant development and specifically identify, say, there's one plant in a batch here, even though they're all genetic clones of each other taken off the same plant, this one is doing differently, even though it's got exactly the same conditions. If a machine learning system could identify that in a way that a human eye either can't because of subjectivity or because of not seeing it or not being able to see it, perhaps there's something a camera system can see that a human eye cannot, something in the color spectrum or something like that. Being able to say plants, say, in this corner of the room aren't doing as well. And then we could look into reasons why. Perhaps the light unit is malfunctioning in a way we can't detect or something along those lines. Another way of doing things, because predicting when harvest is very important. It's very labor intensive. We've not automated that part of our process. You can use a machine for plant processing, but it reduces the quality of the product. So being able to say, this is when we think the harvest is, we can get staff in to cover these weeks would be very useful. Harvest monitoring is another thing. So what happens is that these trichomes, the chemical factories, change color towards the end of the harvest. You've got a little chart here that says this is the change in chemical composition. It's very much a generalization, but you pretty much want 70% of the trichomes to be cloudy white and 30% of them to be amber orange. And doing that in person, which I'm going to be doing in like a month or so, involves taking photographs and then analyzing those photographs every day. And we've got about 140 plants in a room. We need a sample size, let's say square root plus 1. That's looking at about 13 plants per room, 3 photographs per plant, 36 photographs a day. That's easily an hour of my day every day. Whereas I imagine a machine learning system could do that in minutes. Not taking the photographs, but I still have to do that for now. So that could be a huge time saver and also help us predict when we need to be on site. So that's pretty much as I mentioned. Really just because we are such a small team of staff, there's only 5 or 6 of us on site at any one time. Anything that could be automated is a huge gain for us. Lastly, I can't give as much input into this as the other ones, but can we look at the size of the buds and the number of the flower buds as they're developing and make a prediction of how much the yield is going to be? This is important for us because we essentially say we're going to supply a buyer with a certain amount of product, and then for legislative reasons, if we have excess, let's say we've improved productivity, I'm not sure if we can do anything with that product if we already have an agreement. So you mean you've made a breakthrough in productivity, but it all just goes to waste because you can't dispose of it in the normal channels. If we could make estimates of that, maybe we can avoid that problem. And it's good to have these kind of estimates for business practices anyway. And of course, I'm certainly no expert on this stuff. So the actual applications could be enormous, and I'd be very grateful to hear if any of you have any ideas. That's all. Feel free to ask me any questions, but I'll be here all day if you want, because I realize I've gone on a bit today. Okay.
Any questions for Orion? In the room? Yes.
Hey.
I'm Dave from ITS.
Hi. You're right.
So definitely I would like to have some conversation with you later on. But right now my question is, from this AI application, are you focusing to develop a predictive model that can actually give you the qualitative index of CBDs produced? Because your third last slide, it focused more on the weight. However, if you focus more on the quality of CBD versus THC ratio, and focus your model around that, you might be able to harvest more quality compounds in a smaller space with even less weight.
I'm focusing on weight because that's what we can test in-house. We are sending our product for analysis to external labs. But for this presentation, I was simply thinking, what data can we generate in-house? Your idea is fantastic. It would just be the case of this isn't something I can do directly. So, but it's definitely possibly an idea.
Might be good to just look at some of the cannabis growers in the Bay Area because their primary focus at the early stage when cannabis was entering the market of alternative pharmaceutical was actually weight, and they have shifted this away. Something to consider, and I'm happy to discuss this more.
Yeah, that would be a really great idea. It would require a bit of collaboration with the companies we're testing with. I was simply thinking, what data can I generate with my on-site? But that's obviously very important to us down the line. Because another thing with product quality is that normally if, say, we've got a 10% boost in yield, and if that's chemical yield in the plant, you would think, oh, fantastic. That would actually legally make it a different product that we have to re-register and cannot provide. We only have a tolerance of, I want to say, give or take 10% on a lot of our chemical values. So if we grew it in a way that it was like a super crop, that's actually a problem for us. But so actually, just from a regulatory value, it's a really good idea. I know it's a very disappointing,
No, yeah.
but it's just
Highly
how
regulated, right?
it's just how it is. It's a medicinal product. It's
Yeah, yeah.
We need to change the system.
It classes as pharmaceutical, right?
Yes,
So it's kind of like different requirements, which makes us the challenge from a Australian perspective also. We must collaborate in a couple of months, also a challenge, because we're operating under much tighter context and just predicting crop yield for something that, you know, things if not exactly how you expect, it's not just. Any other questions for Ian? Christoph?
Sorry, thank you very much for that. Have you considered hyperspectral imaging, for example, to give you some of the quality indicators? I mean, in the previous comment. And then I understand, you know, RGB cameras are cheap, right?
it certainly could be. I really haven't thought of it because I'm just unfamiliar with the technological side of things.
I can give you kind of my perspective, because part of what we are thinking of doing is installing some sensors, obviously respecting space, respecting the conditions, and that has been our mind. Obviously, hyperspectral imaging is more expensive in terms of, you know, buying the cameras and stuff like that. So, but it definitely will give us more information from the spectrum. But
We can discuss offline, but
Yeah.
we have a hyperspectral imaging lab, which potentially you can use it to identify which wavelengths you want, and then by multispectral imaging, once you identify what you need,
yeah, that'll be Interesting.
to push this forward, basically. And that, I think, it would be worth looking at stereo imaging, calculate the volume of your platforms.
So the cloudy versus the reddish tripods that you were focusing on, I think multispectral or hyperspectral imaging would be useful, as
Right.
well as, you know, you can actually quantify the THCs and the CBDs. You know, you need to get the dose.
Yeah.
Good for you.
Yeah, exactly. No, it's a nice test bed because it's kind of uncharted territory to
We
do
have
stuff.
some on the pharmaceutical crops as well.
Mm.
So one of our focus scientifically,
Yeah.
not from a product perspective, is to boost certain compounds that can be produced in plants and actually have this non-destructive imaging. It's worth considering here.
Last question, Simon?
Yeah, no, well, that's a comment, that's a question and a comment just reflecting what was previously being said about the hyperspectral imaging. I mean, the experience with prolonged plant diseases is you can pick those up from a hyperspectral image before you've got invisible symptoms. So, you know, hours after, you know, or a couple, you know, if it takes a week for the symptom to show, you know, somewhere in the middle of that week it will show up in hyperspectral images. So, absolutely worth checking out.
Sounds very exciting.
Brilliant. Thanks. Again. So, thanks. So last but not least, we have Jack. Jack is one of our PhD students based at the University of Lincoln. It should load up. Again, I hope you come through.
Yeah. I think I have to use this remote.
It should work.
Yeah, okay. Yeah, that's fine. I'll figure it out. Yeah, can everyone hear me? Because I'm not a loud talker, so everyone, yeah. Yeah, so I'm Jack. I'm one of the PhD students based at Lincoln. It's under Sustain. And I'm going to give you a very, very brief and quick overview of what my time has been like so far, still in my first year of the PhD project, and roughly what my project is about. So my journey so far, I have a background in computer science at bachelor's level, and at master's level, I have a data science degree as well. Both of these were studied at the University of Lincoln as well, so I've come straight through from undergrad level to now studying my PhD starting in October 2024. So as you can imagine, the start of this project has been a lot of learning about agronomy and the agriculture side of things, since I have more background in the computer science side of things. So it's been a lot of research, a lot of learning about techniques that can be employed in my area of research, things that might be useful to keep in mind going forward. And a lot of that has been helped by my sponsor. So I'm sponsored by Driscoll's, who are a berry breeder and grower down in Kent. They have been giving me a lot of knowledge and a lot of help when figuring out the exact details of the project going forward and what I might want to consider and what they exactly want from the project, as well as training that's been offered by Sustain itself. So we have activity weeks that we go to. This is part of Activity Week right now, where we get to meet and interact with people from all over the industry, animal farmers, people who grow cereal crops, people work in computer science, and take aboard that knowledge, and then we can incorporate into our research and also get to see what's out there in the emerging technologies. As to why I want to do this PhD and why I started doing this PhD, my personal motivation, I love learning, I love to learn. I wouldn't be doing it if it wasn't something I'm interested in, as well as get to experience new technologies that you wouldn't see anywhere else, technologies that are being developed for the industry going forward, as well as get to do and experience new opportunities that I wouldn't get to do otherwise. This talk, I wouldn't do this if I wasn't a PhD student. So what is my project and what have I been studying? So I'm studying leaf canopy estimation and density of leaf canopies for strawberry plants. That picture there kind of shows you what I'm referring to when I talk about leaf canopy. What exactly leaf canopy is just the leaf area of these plants, and the strawberry plants in particular. So what is it? What is a leaf area estimation and what we're looking for? So it's as simple as it sounds. We're estimating the density of a canopy for soft fruit breeders rather than growers. So breeders, what their job is to do is to cross different strawberry seeds and breed strawberry seeds to get different traits that they want to send to growers in the future. Traits such as disease resistance, bigger berries, all these sort of traits are ideal for growing strawberries. And what they want from this project and why they want to know more about leaf canopy density is there's been a trend in recent years where the canopies are getting denser and denser to support more berries. The more leaves you have, the more berries you can support, the better it is for yield and profit. However, that comes with a few problems, a number of problems that they don't want, and it's causing a lot of hassle for them. So what they want to do by estimating the density is when they're breeding in the future, they can get a smaller canopy while retaining yield, so not losing any of that profit from the strawberries itself. So why is it important that we get a small canopy? So this is to basically decrease disease chances. There's a disease that grows inside the canopy called Phytophthora. It is a fungal disease that grows on the crowns of the strawberries. It likes to live in these very dense canopies that are moist and humid. It's ideal for it to grow. So if we get a small canopy, it's going to open that up, increase the airflow through it, which is going to hopefully decrease the disease chance of that on the strawberries. It also decreases the cost of leaf management. If you have less leaves to worry about, you're going to have to spend less and less on actually caring for the leaves, de-leafing the strawberry plants themselves, caring for them. It also makes the job a lot easier because there's less to look at. It also helps with picking. So picking strawberries can be quite challenging when you've got a dense canopy. The leaves can cover the strawberries, hide them inside the canopy itself, which makes the picker's jobs a lot harder. They have to dig through the leaves, and it makes it very hard to see, which can lead to strawberries being left behind and lead to fruit rotting inside the canopy, which is not ideal. So the goal is to basically find this nice combination of a small canopy which still retains a great yield and a high quality of strawberry. So basically increasing the profit by decreasing the cost of caring for the plant. Some motivation. So why we want to look at this task and automating this task in particular. So these strawberry breeders are crossing and growing and managing thousands of seeds a year to try and get a new strawberry variant that's going to grow and go to growers to produce these strawberries. So it can be quite time consuming to collect any data regarding it. So if you think it's bad just collecting a bit of data here and there for one variant, you've got to do that hundreds and hundreds of times a year. So we want to look at automating this task to help them save a lot of time and money. But what are the main reasons we want to automate this task is costs. So again, as I say, it costs a lot to hire these workers to do this. It takes a lot of time as well. So it's time when they can spend elsewhere, such as harvesting the seeds, looking after other tasks, and also doing post-harvest testing. There's also been a lot of shortages in the working industry recently. As we all know, COVID and Brexit has hit the agriculture sector quite hard. It's made it a bit difficult to find work sometimes. So when you do get work, you'd rather than be doing more productive tasks rather than counting leaves and looking at the area of them. Health is another main thing. As some people have already pointed out, these jobs in the agriculture space can be quite strenuous on the health. They're not glamorous, they're not fun to do. So if we can find a way to automate that or make the task easier, it's going to be a lot more beneficial for the workers in the long run, because it's going to be a lot less strenuous on them to do these tasks. So basically, automation is key. Automation is what we're looking for, or at very least some way to make these tasks easier for the growers to do. So why is this task in particular a PhD? Why has this become a PhD? Research is the main thing here. So there is no right answer when it comes to tasks like this. There is no one solution fits all. There is just what I'm calling the best answer, the best fitting answer. So one that's going to hopefully help the most amount of people in the easiest way possible. One can be applied into a large area rather than very specific areas. Understanding. So this is kind of an interdisciplinary research task. So it's taking knowledge from the computer science sector and the agriculture sector and hopefully finding what's already been put into place. So what's been used, say, for picking strawberries, what's been used for disease detection, taking all this knowledge that's already in circulation, combining it, condensing it down to something that hopefully can be used for this task and other tasks going forward, letting us find gaps that are currently in research and fill them so that it helps the commercial space. Most importantly, the main thing that comes away from doing this research rather than industry is time. It allows us time to find the best solution rather than if you're doing this as a grower yourself or a breeder yourself, you might have to just settle for the first answer you find because otherwise you just don't have the time and the money to invest in actually experimenting over and over again and coming up with solutions. So what's next so far? So what have I done and what's next for this PhD project? So I recently had the opportunity to go down to my sponsor in Kent, Driscoll's, where I spent 2 weeks among the R&D team down there who were responsible for breeding the strawberries and collecting all this data and doing all these tests, helping them with some post-harvest testing, such as shelf life testing and bricks testing to get some data for the strawberries, as well as just getting a better understanding of what this project is and what they want from me. Going into the following year, so my second, third, and fourth year eventually. So I want to start looking at designing and prototyping a software solution for this that's going to hopefully allow me to use a camera to measure the leaf area. So rather than doing a manual process, which hopes speed up the task they've got going, as well as start collecting data to help with this and train the model going forward. I want to define the research questions. So far, it's a very broad area that I'm looking at. So I want to, with the help of my sponsors and supervisors, I want to set out what the research questions are and what I'm looking to answer with this research, as well as investigate more about energy modeling. So one thing that's not been looked at too heavily at the moment is this idea of energy efficiency. So any model that we make, anything that we make for the project, software or hardware, I want to make sure that I model and research the best practices for keeping as energy efficient as possible, which will make the whole project be sustainable, rather than just finding a solution that might be very energy intense. It's not going to be very good for the environment. So we want to make sure that anything we do is efficient with energy, so we keep it sustainable. Yeah, thank you. Any questions?
Great, thank you, Jack. Any questions for Jack in person online? Simon.
So you talk about leaf area index. I think you really need light perception because light perception was drives most of the system out light.
Yeah.
Leaf area index is one function of light perception. So to get the basic principles a little bit might be helpful as well. I don't know.
Yeah, it's something that I've looked a little bit at is this idea of light intercept. At the minute, because I'm still working with my sponsor, they want this idea of, I say, getting a small canopy to help us increase these chances. So I think going forward, it's something that when I collect the data, I would like to look at how I can collect the light index as well, because that's going forward. Because it's all good having a light canopy, but if all the leaves are stacked on top of each other, it's going to be very inefficient with growing it. So it's something that I know of, but I do want to look further into as we go forward.
Yeah, you're going to use synthetic data when you can see lots of opportunities to generate synthetic canopies to test what the shape is. I can see lots of roots.
Yeah, it's not something that I've thought of, but that sounds like a good idea. Yeah.
Any more questions for Jack? No? If not, thank you, Jack, again. Thank you. So we finished the presentation part. We've got about 10 minutes before we head back for lunch. It's an open session now for Q&A. If you have any questions online or in person now, it's more an open discussion. Anybody would like to know more about Sustain? Yes, please.
Hi, first off, I'm from the farming sector, so thank you welcome to everyone who's spoken, particularly Jack. That was a great presentation. I don't know who this is aimed at. This is more of a thing about just the general structure, but one of the frustrations we've had around the farming co-op, quite a big one, but the challenges we've had with UKRI traditionally, in fact, the industrial strategy this week kind of doubles down, is that one of the key things for funding a project is the return on the investment, which bluntly comes from selling something to farmers. What we found really quite challenging is to design projects where the farmers are the beneficiaries of the project rather than the people who end up ultimately getting someone flogging them or something. And particularly in this realm, a lot of the value comes from the data. And with some of these projects, you run the risk where you're going to take the farmer's data and then you're going to sell them something back to them. And there's a bit of an ethical question in amongst all of that. And I think particularly when it comes to the food systems one, there's huge value in this technology in delivering societal good. But you're going to struggle to write funding application because your return on investment in delivering societal good, because the beneficiaries are the millions, not here's a company that's going to sell this many in year 2, which is worth that much in its return on investment. I'd be interested in views on whether we can move beyond that slightly simplistic measurement of a good project.
That's a very good point, actually. I mean, quite spot on. That's true. I guess many other projects, especially funded by Innova UK, maybe they are more into kind of quantifying the return in kind of more KPI-based approach. But I would say that at least for doctoral training programs like Sustain or similar ones, the objectives are slightly different, obviously. There's a research component to that, there's a co-creation component with the company. Obviously, you have to present that there's a benefit for the company that's supporting a specific project. But following UKRI's perspectives, everything, it has to be open access, open science, open publications, source code, and we have to abide by that. So any other view, Simon?
Well, so I think you're absolutely right in terms of the standard route for things like Innovate, right? Well, yes, and part of that is writing a business plan, and it's doing that if it's stuff you're trying to create that way good. And I think it's always going to be challenging, right? It's going to have to be a different vehicle for that, because it's always going to be something. What you're saying is reminding us the conversation we're having with folks at James Hutton yesterday. So that's not something that we consider relevant in your case. Sorry, close enough to your bag. It's something about pigs. Right? So this is on the livestock side. Right? This is very much a plant thing. But the idea there is that we develop a system which will do things like help predict yield and growth, and look at various management strategies you can apply as an arrow. And their hope is that you can get people to engage, and as with many people in the business, that around us having trouble persuading people that there's, as you say, there's value in data, but in their case, they need your data in order to be able to, and need data from lots of different people in order to be able to generate those good predictions. But the offer there on their side is, well, okay, we understand you're reluctant to give us data, but look, if you do that, then we can give you something that's of value to you back, right? And I think maybe there's a space there, and that's perhaps the value of part of that of engaging with academic institutions, which our metrics are not about making money, right? As George said, our metrics are these weird things like outputs, and in fact, generating public good. If we can find a way of quantifying that is one of them. So I think there's maybe a space there for depending on exactly what the problems are, but to create there's kind of sort of a space where it's okay. If you're happy to give us data, we can give you useful things back that help you meet your KPIs. And we're not about creating a product. It's a trade, right? So there's a cash trade. Yeah, it's a kind of in kind. Give us this, and there's along with all these guarantees that we're not going to give you data from
Yeah.
identity and anonymity and all that. So it's maybe almost sort of a trusted third party aspect. But yeah, we can maybe act in this case. Because yeah, you're right. The last thing you want to be in is a situation where yes, you give us your data and we sell it out to you, right? There are many people who will do that to you.
Yeah. I think Simon has.
One of the good things, I mean, the many bad things about being in a university right now in this state of the world, one of the good things is we're not quite under the pressure that forces us to be in a situation that's very bad. Right? So, sorry.
No, Simon has a few points.
It's a really good question. I think from the logic model of the industry strategy, what we're trying to do is pretty well done. So it's aggregating companies to drive the aggregating companies that was where new businesses there. By funding those companies, they generate outputs, which is aggregating companies, and then the outcome, which should be new products by the aggregate, which is the selling. Then the impact is a better environment. So I think the logic model is absolutely spot on. I think where it goes a bit wrong is the business model bit between the ag tech companies and the farmers. I don't think there's probably enough co-creation around that. I think we've not got it right. You've got this combination of some startups pushing too hard, don't really understand the farmers business, they use co-creation. And you have on the other end, you have farmers who have unrealistic expectations of what tech can do, and they use co-creation. We've not quite got that sweet spot, the middle figured out, and I think that's where we need to really think hard, because we do, certainly limited amount of resources, we need to work hard for everyone to use taxpayers' money. So that middle ground, we're not quite got it, and we don't quite know what the answer is. We need to figure it out.
It seems that there should be space for even if there's at the end there's a product being created that's going to be sold to farmers to involve to say, well, you've been involved in the creation of this thing, right? And you've supplied the data that's got us to a point where we have a product, then part of the value you get back to that is the thing that's being sold elsewhere. So it's not a case of right, we'll take the data and sell the product. So when you get the product because you created this, right? And you get, because you effectively invested in it, you get some of the value, some of the value flows back to you from future efforts to sell it. It seems to be an obvious thing, you could find something in that space.
I think the other thing is, I think one of the reasons the data sharing thing has failed is a sort of lack of trust thing. So I'm giving you my data, you can say it back to me very much. That's so, but because the middle bit, the business model is not really well thought through, you don't know what you're getting back for sharing data. I think it was a bit more transparent than that when you look on the whole. So what we're looking at, we're trying to sort of well, absolutely, because we're trying to have an open dialogue where you say, well, okay, if you save £1, 30p has to go in the cost of saving, 30p goes into the staff, 30p goes back to the farm. Or something like that. I think if we had a bit more clarity around that, people would be a bit more
Tanvi, yes.
No, I think the point that you raised is fantastic, and your contributed, exactly said what I was going to. From the industry side, there's something that I thought would be useful. Like, let's say we work with you, we get the data. Getting the data back is of no use. Frankly, what you need is a tool. And this is global. So many people will talk about like, oh, we need data. Excuse me. You need a tool based on the data that has been used to build up that can, help you further. And I think based on the model that Simon was describing, I think it's quite important to bring that in some form when the grant applications are filed or when the startups are funded. We can have something like early adopters discount, okay, or some form of like lower royalty payments compared to the other customers that would be second-tier customers. So I think that just needs to be thought about, not just from UPNI and the funding agency, but even from the startup angle and the farmers.
So, and It's the profit.
Profit share,
Oh.
yeah,
I can see how you can do that bit of it,
yeah,
but let's think about something which delivers 5 bits of fruit a day of veg
yeah,
to all the people in the UK, and obesity drops to 10%.
Yeah.
I don't see how you write an application within
Mm.
the current structures
Mm-hmm.
for a tool that delivers that. It's got massive benefits, but it's disparate.
Yeah.
The NHS will benefit, everything, blah, 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 but they're not going to come and write with that application. And it's how do we're missing a bit of it. We're missing out on hugely valuable applications of the technology because we have a funding mechanism that is quite predicated on profit.
yeah, exactly. And trust me, we have tried some of this stuff, like, for example, what John was describing about the slotting, based on just even considering multiple dimensions into that, so that we have a full footprint model for a crop. So that farmer can actually push the button and see how it needs to go. What are the gaps, whether it can be infested by abiotic stress or, whether by pests or disease or anything. And we had this conversation with some of the other collaborators in academia to make it open source. Again, industry would have to take some steps in that direction. Like, for example, in John Deere, now they are leaders in precision ag. But 15 years ago, when we were generating data based on the farmers in the United States, Deere wasn't there. It was IBM who was doing that, and few other companies, and then they collaborated. But they are giving back to the farmers in terms of like satisfaction of royalties or early adopters. So I think that model needs to be adapted here as well in this industry. And I completely agree with you. I mean, it has to be like whatever tool is developed needs to be open for other industries to use. When we talk a lot about agriculture-based tools, but one of the things is business-based tools. Decision-making in business for startups, for example, was mentioned, most of the startups fail. And one of the challenges is they don't have a clear business strategy. So there's something to be done.
I guess you're saying that you're open sourcing that model, even if it's open sourcing that model, how does the farmer use it? So you need someone to provide this as a service as well, right? And because who's paying for that?
But the point is, like, we need to bring people together to make these things happen. Otherwise
Can I make a suggestion? Because we are running out of time. Elias can provide any, do you want to provide some input? My recommendation is that we have lunch and you can carry on discussing over lunch. And then we have the session in the afternoon, 1 o'clock, for the different subgroups, which actually want to capture all of that component there. So we have much more time to discuss that. Final point.
This point is very useful, but I'm not sure that I fully agree on it because there are economic frameworks now that are able to calculate the impact of public goods. Yes, I review quite a lot of proposals for ESRC, which is the Economic and Social Research Council, and you can see, for example, for proposals that deal with antimicrobial resistance, that it's a classic example. They say this costs us so many lives, this costs us so much disinfectants, antibiotics, etc. So there are frameworks to calculate that. In agriculture, we don't usually use this, but the medics do.
Yeah. So there is a mechanism.
So there's a very good, there's a very, I think you can read it, right? Very nice point made by Luis, like loyalties, like for the data that you are, yeah.
But I think there's another piece which is just to finish up, which is that if your provision of data is critical in somebody getting a product developed that they then sell, I think that's an investment just as somebody can only get a bunch of money, right? To hire a program. So I think it's more than just preferred, vendor status or whatever. You're a shareholder, right? And then how you compute, the value of the donation of data. But I think it should be at that. My view is it should be at that. You are a foundation. It's absolutely dependent on these insurance of data, so you get value.
Brilliant.
Okay, lunch.
Let's close it here. Thanks everyone online. Now we break for about 42 minutes for lunch. and then we reconvene at 1 o'clock in person and online. So see you all in 42 minutes. Yes, yes, indeed.